Welcome everybody, and thank you for joining the second installment of our GeoMagic Control-X Product Spotlight series. This webinar is focused on the airfoil analysis functionality in GeoMagic Control-X. I appreciate you joining us today, and I hope you'll be able to join us on future Product Spotlight webinars as well. A few housekeeping items before we get started. As you may have noticed, all attendees' lines were muted upon joining the webinar. Therefore, please use the Q&A button on your screen to submit any questions as we go along. In an effort to abide by our 20-minute time allotment, we may not have time to address questions live during the webinar. If that is the case, we will follow up with you after the webinar with an answer to your question. Additionally, we will make the answers to all frequently asked questions available for all of you who have attended. Finally, in a couple of days, you'll be receiving a follow-up email with a link to view the recording of this webinar, as well as a copy of a sample file that can be used to trial the airfoil analysis tool. Once again, thank you for joining us today, and I will now pass it on to Chris Schneider, a GeoMagic application engineer, as he will be leading today's demonstration. Chris, it's all yours.
Cool, thanks Adam. Hello everybody, like Adam said, my name is Chris Schneider. I'm an applications engineer here at 3D Systems, and we're going to be walking through the airfoil tools that are included inside of Control-X. So these tools are built right into Control-X and are just easily accessible in the tool palette. So these tools are specific to extracting information directly from airfoils. They're a nice, easy way to extract meaningful information from any blade that you're looking at. So we're going to go over some 2D comparison tools, some 2D measurement tools, as well as a 2D twist tool that's included right into Control-X. So in the 2D measurements that we're going to look at today, there are some things that the information that you're looking for is pretty common, so we've kind of made them the quickest and easiest way to extract them. So we have some previews on the screen here today. So the workflow starts with a 2D comparison to look at the cross-section and actually look at the data to give you a preview of what's going to be extracted and the shift in the scan information, as well as very quick and easy ways to extract robust metrology-grade 2D measurements from the specific cross-section you're looking at. So after we finish looking at our 2D measurements, we're going to be looking at the 2D twist analysis that's also included in Control-X. So the 2D twist analysis, instead of looking at lengths and distances and radiuses, what we're actually looking at is a cross-section of the blade where we take a section and we have our reference information, and we're going to also take a section and look at our scan information. And we're going to best fit those two sections together to give us a twist analysis. So what that means is we're finding a center position, and we're either rotating around it or we're translating from that position. We want to see the difference of those numbers. And what that means is that we get to evaluate the manufacturing method of this blade, and if we need to change that, or maybe adjust that in the future to get the blade that we're actually looking for. So we're going to jump right into the demo today. So if we hop over to Control-X, here we go. So what I've done already is that we have our reference information here. So we have our solid file, which is the blade that we wanted to manufacture. And then we took a scan of the blade as well. So we have these two information inside our file, and what we're going to do is we're going to align those two pieces together. So the first thing we did was align them together with the initial best fit alignment, and then we did a datum alignment with the roots of our blade here called out. So this is a typical practice and application. We always align to the roots, since this is probably the most confident we are in our blade, because the blade portion is the part that usually has some deviation into it. So the standard tools are acceptable, where we can look at the blade using the standard tools, but we're actually going to hop into the airfoil tools, and they live under our compare tool set. So these have some more interesting and unique applications that we have in Control-X. So if you're interested in them, definitely let us know. We can go into them, but we're going to look and highlight the airfoil tools today. So we have our airfoil analysis tool, and we have our 2D twist tool. So these are two separate tools that we can use to extract information. So they require very little setup, so all we really need is a blade that we're going to look at, and then we can go right into it. So we don't need our scan information. We can always set up a template inspection and go from there. But since we have them both in here, we can instantly get measurements from our inspection process. So we're going to hop right in. So the airfoil tools are a multi-step process, and it takes a preparation step, and then we have some measurement steps after this. So the easiest thing to do here is have a datum plane that intersects the blade portion of the blade, and then we can go take analysis from that section. But what's just as easy is that we can take an offset from either the top or the bottom of the blade. So if we have some callouts in our drawing that say we need to go down so many inches or millimeters or percentage, we can definitely do exactly what the drawing says. So for this blade, we're going to take an offset from the bottom of our mesh. So we don't have to create a reference geometry from the bottom. What we can do is actually use the CAD recognizable features inside of Control-X to just treat the bottom of our blade as a plane and then offset from that position. So I went ahead and hid the scan information, and we have this offset arrow. So what I can do is I can just click it up and down, and I can see that I have a preview of our 2D section right here. So if I turn our scan information back on, you can see that this color, 2D color map starts to represent the deviation between the reference section, which is our solid, and our scan section, which in this case is blue. So we can change the offset or take multiples of these and take the evaluation there. So after we set up the desired offset location, we go to our next step. And our next step shows us a 2D comparison of this section. So we took that offset from the base of our roots, and then now we have a color map of the difference between our reference and our test, or in this case, our scan. So we have the color map that shows us the value of that deviation. I can also run my cursor over the lines and see what that number is. And here we can look at a little bit closer and see that the solid black line is our reference, so our CAD, and we have this colored line which represents our scan. In the center of this cross-section we have this dotted line, which is the center line of our blade, and this is going to be something that we're interested in, and it just visually represents this information for us. So we can change the visual display of this section with these sliders here. So we can make our whiskers bigger or smaller, right? And this kind of highlights some of the deviation in the actual surface profile of the section that we're interested in. And we can also increase or decrease the density of these points to make it visually more appealing to look at in our report or in our view. And on the right-hand side, we have some properties that go and actually take some information from this cross-section and gives us some numbers behind it. So if we're looking for the area of our reference, so the reference area of our cross-section, I can just click on that number and we can get the area value there. We can also do the same for our measured information, which is the corresponding slice on our scan information. So it's very easy to extract this information just by clicking on it. So the next step is the more robust measurement step, and this is very quick and easy. So all we have to do here is check the box of the measurement that we're interested in taking. So we do have to tell the software what direction is our leading edge. So when we go and check our leading edge radius, we need to guarantee that it is the correct direction. So in the middle of our screen, we have this X and our Y display. And this is our local 2D orientation. So we can see our X is our positive X is in the right direction. So that means our negative X is in the left direction. So we can visually see that our leading edge direction is on the positive X side. So I can just go down here and drop this to our positive X. So when we start taking our measurements, they're going to populate in the correct orientation. So since we anticipate extracting this information, we don't have to create any additional reference geometry. It's really easy to just click some of these boxes and give us our information. So as I go through and I select this measurement to be taken, these numbers just populate on the screen. So I can click and drag these out, just like a regular 2D cross-section, and I can evaluate these measurements and see what their values are. So if we're looking at our leading edge radius over here, I can look a little bit closer, and I can see we have a dotted shape here, which this represents our scan information of the leading edge radius. So if we hover over the actual measurement, I can see the circle that represents the reference information and the corresponding scan circle, which is slightly larger. And then we have the actual evaluation in green here. So these numbers populate in the bottom toolbar here. So if I wanted to go a little more granular and look at the values of these deviations, maybe change some of these tolerances, I can easily go in here and adjust these values. So these are quick and easy measurements to extract from our blades in a very easy fashion. So another common interesting measurement that we're interested in is the thickness offset from a leading or trailing edge position. These are very easy to update as well. All we have to do is click this box, and then we have this offset value that travels along this center line until we have the required offset or the desired offset value. So if we wanted to change this live, we can just click it, and our measurement updates accordingly. These are really quick, easy measurements to extract robust metrology-grade dimensions from our airfoils. So moving on to our 2D twist values. We can see that we have an airfoil section in our model manager. So this section actually holds all the additional information that we could want from our section, including any reference geometry that we might want to reference later. So if we wanted to take additional measurements, all this information is located in our model tree. So we have this visual representation of the cross-section on our blade, and we can hide this if we're not interested in seeing it anymore. So going to our 2D twist analysis here, this is set up the same way. So we can choose a datum plane or a global reference plane to take our cross-section. And from here, we're going to do the same thing, except we're going to take a slightly different section. So we're probably going to offset a little bit higher on the blade. And this has the same preview. So remember, what we're trying to do here is look at the local 2D twist along a cross-section. And what that means is that there is going to be some sort of deviation, and we're interested in what that deviation is. So we go along here and go to our second step. So what our second step shows us, if we can show our comparison here, is that we have the same representation as our airfoil cross-section, except we don't have our center line here. So we have our solid line, which represents our reference data, so our solid, and we have again our colored line, which represents the scan information associated with that. An interesting thing here is we actually have a centroid a representation here, which is the centroid of this cross-section, and we can choose to not use it. So this can be updated depending on the actual implementation of your company and how you want to analyze this. So you have a little bit of control here of how we can update and evaluate this 2D twist analysis. But this is also very quick, so we just specify our options on how we want to do it, and these measurements automatically evaluate. So these measurements populate into our Properties tab on the right-hand side, as well as the tabular view at the bottom. So if we're interested in actually seeing what these twist values are, we can just scroll down here and we have these values in our unit that we're using. So today I'm in millimeters, so I have 0.7 millimeters twist along the X direction, or translation along the X direction, and the same or a slightly different value on our Y direction, as well as the angle that would be twisting on this cross-section. So these can be updated again if we want a more visual representation of what these numbers mean. We can make these whiskers bigger or smaller and kind of get more information here. So once we say OK here, we again have an additional option in our model tree that shows us a 2D twist that shows us all the values that we just extracted from our blade. So these are pretty easy to extract. They're very quick and nice and easy to get additional measurements if we are more interested in getting that information. So if we hop back to our PowerPoint, there are just a couple more comments that I'd like to talk about. So since we go through and set up our inspection process on our reference blade, we have the ability to automate this process. So what we can do is we can change our scan information just as easily without changing anything on our reference. So that means we can have however many blades in our row, and we can go through the same inspection process using the same approach, the same alignment, and report out the same values on each and every blade to see if there's any trend or deviation that we need to look at and change. The other thing that we can do here is we can use a scan reference. So that means instead of taking a CAD object, so the original manufactured blade that we wanted to make, and use that as our reference object, we can go ahead and take a scan of a blade, do something to it, and then take a scan again and see the difference between those two things. So maybe we needed to polish it or do something to it. We can see exactly what that process did by setting that first scan as our reference object and then extracting any of and all of these deviation values with our new test object. So that concludes the short demonstration we had today on the airfoil tools that are embedded in Control-X. If you have any more questions on the applications or solutions that 3D Systems can offer, please visit our website at 3dsystems.com. For any sales information concerning Control-X or applications or additional tools, please visit or email our sales team at geomagic.sales.americas@3dsystems.com. If you're interested in trying Control-X for the first time, you can download our trial and talk to our technical support team with any questions that you might have at gettingstarted.geomagic.com. And as Adam said, we have a sample file, so we have some test information for you to play around with on a demo blade that will show you a little bit of how to do some of these measurements. All right, thank you. And Adam, back to you.
Thanks, Chris. Well, this brings us to the end of our GeoMagic Product Spotlight webinar on airfoil analysis in GeoMagic Control-X. Please be on the lookout for invitations to future Control-X product spotlights from 3D Systems. In the coming days, each of you will receive an email with a link to the recorded version of this webinar, also some useful links regarding Control-X and answers to frequently asked questions. If you asked a specific question during the webinar, we will be sure to follow up with you with an answer to your question in a timely manner. Thank you again for joining us, and have a good rest of your day.